Hello, my name is Miss Player, and I'm going to show you how to create appropriate data tables for your DP Physics IA reports. This is part 1 of a 2-part series. In the part 2 video, I'm going to show you how to transform your data into an appropriate graph. We're going to be using data from an investigation where we find out how the length of a pendulum affects its period of swing. And eventually, your report is going to want to look something like this, where you've got your data table of raw data, and then you've got another data table of process data, and then you talk about all the equations that you use to determine uncertainty and include your qualitative data, and then eventually you have your graph with error bars, max and min, and best fit lines. Again, I'm going to show you how to do this graph in part 2. So right now, let's focus on the data tables. So we open up a new workbook, and you saw that the length is the independent variable. That's what we change. There's the title. The symbol for length is L. And the uncertainty is 0.01 meters, or 1 centimeter. But we want it in meters. Now I click on that cell, click wrap text so that it fits in one cell. And then underneath I put my lengths. So the highest is 1 meter, and I want it to the same decimal precision as my uncertainty. However, Excel is not letting me do that, but we can fix that later. So I'm going to put in all my values. Okay, I'm going to highlight these cells, click on Increase Decimal Precision until I get to 2 decimal places, which matches the decimal precision of the uncertainty. Now in the next cell over, this is going to be the time it takes for 10 periods of pendulum swing. So 10 periods of... Now the symbol for period is capital T, but we've got 10 of them, so it's 10t. It only makes sense, plus or minus the uncertainty of the stopwatch. Okay, I'm going to wait to merge these cells across. I want to first put in my trial numbers. And I've got 3 trials. Sorry, 5 trials. And then in the last column, this is going to be my average of trials. And I put in that equation, so it's bracket the sum of all my trials, close bracket, divide by 5 because there's 5 trials. Okay, I'm going to click on that cell and select wrap text. Now this heading applies to all 5 trials in the average. So I'm going to highlight that and click merge and center. Okay, now I've got data already recorded for my 5 trials. So I'm going to, that's not it, I'm going to copy and paste those values. Oh, okay. I'm going to drag this down. Oh, come on. There we go. Merge those. Okay. Now we're okay. All right, for my first row, I want to show this calculation, this equation in action. So I need to show how we did that with our data. So you see here that it's the sum of all 5 of these trials, right? Divided by 5, which gives us an average of 21.48 seconds for a length of 1 meter for 10 swings. Now for the rest of these, I can just type in an equation. Make sure that the sum is in closed brackets before you do the divide by 5. Okay, and the average is calculated for you. Now, if you put your cursor in that cell, you see a white cross. If you bring that white cross to the lower right-hand corner, it turns black. You can click and drag all the way to the end, and all the averages are then calculated for you for all your trials. This needs to be to 2 decimal places. So there we go. Okay. So this is your raw data table, with the only exception being that the average is processed data. I'm going to highlight this. I'm going to just make sure that it's all in the same font. Okay. And then I want to go to Format, Cells, Border, Outline, Inside, OK. And I also want to just distinguish my headings with another color, so I'm just going to give it a mild gray. It's pretty dark. Let's go a little bit lighter. Okay. I think that looks pretty good. Okay, so I'm going to copy this. And I'm going to paste it into my report. Notice that I've got an appropriate title there for my data table. Okay, we're good to go. Now I need to make a process data table. All right, I'm going to copy and paste the length of the pendulum so that I have the length as reference. So in the next column over, this is going to be the average period of 1 pendulum swing. Just give them a symbol T, which equals 10T divided by 10. And that's going to be plus or minus an uncertainty that we haven't calculated yet, and so we're just going to put delta T there for now. How I create that delta symbol is option J. Okay, click on that cell, wrap text, and merge. Is it all there? Okay, good. Next cell over is going to be the uncertainty of average period of 1 pendulum swing. Okay, this is going to be delta T, and that's going to be equal to my maximum trial minus my minimum trial divided by 20. The reason why I'm dividing it by 20 is normally I would divide it by 2, but because my trials are all 10T, then I also have to divide them by 10. So that's why I'm dividing by 20. And the unit is seconds. All right. Wrap text. Merge. It's not fitting, so I'm just going to reduce the text a little bit until it does fit. we're okay. Next column over. Now we are trying to plot the length of the pendulum against its period of swing squared. So we have to square t. Okay. Is it all there? Yeah, we're good. And then finally, we've got the uncertainty of the period squared. Okay, the uncertainty of the period squared is delta t squared, which equals 2 delta t times t, and the units are in seconds squared. Now, where does that come from? Let me show you really quick after I wrap text and merge. Is it all there? Yes, okay. This is a proof. What just happened? Okay, I don't know what happened at the top there, but oh boy, what on earth? Get out of that. Okay, well basically delta t squared over t squared is going to be equal to 2 delta t over t, and when you multiply both sides by t squared, then what it breaks down to is 2 delta t times t. Okay, if you don't know how to figure that out, then just let me know. All right. We've got equations to put in here. Average period of one pendulum swing is going to be this average divided by 10. So I already have that. I'm just going to copy all these examples and explain. Okay, so the average of 10t for 1 meter divided by 10 gives us that for the average pendulum swing. Then the average period of one pendulum swing is delta t, and for 1 meter that's going to be, these delta t's are all going to be unique. So that's max t minus min t divided by 20. So my max was 21.66, my min was 21.29, and then we divide by 20. Again, this is divided by 10, and then also divided by 2. Okay, and then period of one pendulum swing squared is going to be the average period of one pendulum swing, 2.15, in this case, squared, which equals 4.62. And then finally, the uncertainty of period squared, which is equal to 2 delta t times t, so 2 delta t, which is 0.02, times t average, which is 2.15, which equals 0.09. All right. So now that we have that, we need to put in our equations. So this is relatively easy. This is equals and the average of 10t divided by 10. White cross, black cross, drag. We want this to 2 decimal places. Okay, here it's average period of one pendulum swing delta t, max t minus min t divided by 20. Now you've got to painstakingly figure out what your max is, what your min is, take the difference and divide by 20. So I'm going to just cheat and show you what I got here. Okay. And then my next column over is period of one pendulum swing squared, which is t squared. So it's this value squared. So equals this value squared. Okay, white cross, black cross, drag. 2 decimal places. Just want to make sure that it's there. 4.13 to 0.45. Okay, good. And then finally, we've got the uncertainty of period squared, which is 2 delta t times t. So 2 times, this is going to be delta t, okay, times t itself, turn, white cross, black cross, drag all the way down. Okay, I'm going to reduce decimal precision. It's supposed to be to one significant figure for the uncertainty. That's okay. I could just leave it like that. All right. So we're almost there. Highlight the whole graph. Just make sure that it's all in the same font. And format, cells, border, outline inside. Okay. Highlight the headings. Make them gray. I think we're okay. So I'm going to copy this process graph and I go to and paste, showing that I've got an appropriate title for my process data. Now once I'm in Word, I can actually change these to superscripts. I'm not able to do superscripts in Excel, not that I've found anyways. So I can change this to superscripts once I'm in Word. Did I get all of them? Hopefully. Okay, and this concludes part 1 of the video series for how to make data tables for your DP Physics IAs. In part 2, I'm going to show you how to make graphs.